Bryan Shackelford is here with me. I'm Jan Shumate. We're with Eastman, and we're going to share our digital twin story. We have the enviable pre-networking time slot, so we're the warm-up act for networking. But we're very excited to share our story with you, and ours has a little bit different slant than the one that was just shared from Kimberly Clark. We want to talk about how we've accelerated our digital ecosystem along with our sustainable journey for a sustainable advantage in how we deliver our products at Eastman. And both of these are near and dear to us. Stock image there on the screen for you, but that looks a lot like where our facility is located. So sustainability has a special meaning to us. If you've ever been to Kingsport, Tennessee, you'll know that it looks a lot like that. And so we're excited to share with you how we've brought the digital together to empower the sustainable. All right, so a little bit about Eastman. If you're not familiar with us, we are 102 years old now. We were founded in the mountains of East Tennessee by George Eastman, who bought a methanol plant there that could produce chemicals for film developing and secure his supply for those following World War I. Today, we're a Fortune 500 specialty materials company. And what that means is we make all kinds of different products, everything from beakers of chemicals to tankers of chemicals to discrete products, yarns, filaments, rolls of film, and some unique new products that we're going to share with you in a little bit today. We had a little over $10 billion of revenue last year. We've got 14,000 employees around the world. If we talked with you last year, we have 50 manufacturing sites around the world. Right now it's 40. We're going through a redesign. We've limited some of those facilities to be able to build new ones around the world, and all of those are coming on board as part of our digital ecosystem. So to start out, I'm going to lay the groundwork, and Bryan's going to share the really exciting things with you. To get the digital twin, we really had to build out our digital ecosystem to begin with. And Bryan and I have had a really fantastic journey the last 8 years. We started in the engineering, procurement, construction space, which is called design build in other parts of this presentation. We were using digitalization, automation of data to eliminate manual efforts. We were able to automate drawings. We were able to automate some of the design work that took place. But our main goal was having information available to everybody who needed it wherever they were. And that was our SEGA process, Seamless Enterprise Information Global Access. Being able to pull that data together, a lot of you are from the chemical, oil and gas industries, and I assume that this is true for a lot of owners, operators. Having data is not a problem for us. We have plenty of data. Having it in a structured, uniform language where we can view it, where we can have access to it, know that it's accurate, know that it's reliable, that's the challenge. So we started on that journey 8 years ago in the engineering, procurement, construction space. We used that for construction using advanced work packaging to build construction digital twins. We actually build a digital twin of our construction process, how we're going to build that facility. Then we do real-time progressing as we implement those packages. So it was frustrating to us. We come to things like the ARC forum, and we're not really limited by life cycle here. We talk about the data and the ecosystem in its whole, but we were kind of isolated to that engineering, procurement, construction cycle. So a year and a half ago, all of our wishes came true. We got a new job assignment, and they said, y'all can branch out. We want you to look at our overall manufacturing ecosystems. We want you to modernize our manufacturing processes. We want automation. We want digital twins across the board, not just for our new facilities as we build facilities. And it's been exciting ever since. So that's really when we started out building out the other elements you see here. We introduced robots and drones for our inspections on new construction, for elevated inspections, asset integrity. Connected worker. I mentioned that SEGA started out as the right information wherever you were, anywhere in the world. We really thought about laptops when we were starting that 8 years ago, but that message has been able to transcend. We now have mobile devices. So our workers can pull up whatever they need to do their job wherever they are with instant connection, with the right security protocol. We can leverage that for them to do digital permitting, lockout, tagout, as they're going through their daily operations, and digital procedures as well. We've got digital track and trace to keep track of our materials, to keep track of our work packages. and mechanical automation, where we're actually introducing robotics and new manufacturing information, new manufacturing trends and styles in our where we produce the product. So all of these were foundational elements for us to build out our digital twin. There's another element that's left out. I have another colleague here from Eastman. Steve Smith is with us today. The other element is bringing in our OSI Pi operating data and marrying that with our models, with our access to information, so that we can see that real-time picture as well. So that's a little bit of the background of the foundational element that we've been working on for quite a while, so that we can jump into the digital twin phase. Okay, it worked up till now. There we go. So another exciting thing that's been happening at Eastman, while we've been harvesting data and putting it together in a meaningful way, I mentioned we're very focused on sustainability. So we're actually building right now a world-scale polyester material recycling facility in Kingsport, Tennessee. That's our corporate headquarters. In the keynote address this morning, you heard the discussion around mechanical recycling. Our facility is a chemical recycling facility. We actually take our feedstock, which is waste material, and take that hard to break down PET, carpet, textiles, over 110,000 met tons a year. And through our new capital facility, we're able to break it down to the molecular level. So it actually goes back to its molecular level. We use that as a feedstock. In this particular application, we are feeding our Triton copolyester facility, and we'll be able to generate between 150 and 200,000 met tons of polymer annually. So that's neat in itself. That's an exciting concept and exciting for our company, for our partners, and for our off-takers. But it's also exciting how we've incorporated our digital elements, our automation elements, and the digital twin. This facility, we've used all of the tools that I mentioned a little bit ago in the design, in the build, and ultimately in the operation. The folks who work here have their tablets. I love that Dick covered that a true digital twin looks at supply chain. There's a lot of trucks involved in this process. They actually model those trucks coming through. They know where the trucks are with material, when they're headed in, when they're moving between facilities. So we're able to see all of that as part of the twin and on our handheld devices. But the really cool stuff, I got bumped. I had to go first with the introduction. Bryan's got the story of the really cool stuff of how we're actually leveraging this for our advantage. A lot of our business is getting from concept to molecule in our customers' hands as fast as possible. And Bryan's going to tell you how the digital twin is enabling that for us.
All right. Okay. So I'm the only thing now standing between you and happy hour, right? All right, I'm going to try to be the drop of vermouth in your martini. How about that for a promise? So we're coming up on this. Remember, acceleration was key in our title. So how did we accelerate? You have all the groundwork now. You have even the data modeling, great presentation by Kimberly Clark. You've had a ton of work done over the course of the whole ARC up to this point, and it's more in the future. And I hate to tell you, but when it comes to digital twin, it's all true, all of it. So let your nightmares begin. In this particular case, we had acceleration due to this hot project, which had all of the bells and whistles thrown at it. And so we had a promissory note. We're going to do a digital twin. This is a mandate. And then what happened? Well, you know, as it turns out, our leaders like to be pretty forward-looking. So before I could finish the first digital twin, which was Greenfield, and we have two other potential digital twin pilots. One is Brownfield. The man who is leading that is right here, Stephen Smith. If you will stand up and wave your hands so that they can mug you later. Thank you. And the second one is in training in Texas, following a sort of a hub and spoke training model using digital twins in that particular respect. It was announced we're going to do something in France. And one of the guys who likes to joke around with me a little bit said, "Dude, your twin's going to have a twin." Whoa, dude. So we definitely had to accelerate. In order to do that, we needed to add a visual component that we didn't have. Visual fidelity has always been present, even if it's, an ASCII characters on a green screen. Back when I first started doing things, I ran solid state models for polymerization, and those things were awful. They were ugly, but there was all of the elements present, that we talk about with regard to digital twins, including the data. Even a low fidelity visual, right? So I could see how hot my nitrogen gas had to be coming out the cone of this column, and I could see the numbers resulting, and I could call the control room and say, hey, turn your temperature up or down or whatever, and they would say, no, my control doesn't say to do that. But now we have to accelerate today's version of data. We have to accelerate the project. I have left brain and I have right brain going on at the same time because we started constructing before the design was complete. We're pouring concrete, we're putting rebar in the ground. I have to have something ready so that when the virtual and the actual come together, we have a twin. I added the visual component and it was like lightning in a bottle. I had always been told by my professors back when I was taking CAD courses and so forth in college that not everybody thinks three-dimensionally. What I did not realize was that even mechanical engineers don't always think three-dimensionally. When we added in the visual component, and by the way, I'm not going to read my slides to you. You can infer what some of those things mean. Those are return on investment that we're already seeing. But when we added the visual component, this thing took off like a shot. People who had been living with the project and with the data for months now suddenly were able to add a human element to the entire affair that they had not had in the past. The safety rep understood what he needed to ask for. The training manager understood what he needed to lay out in the way of curricula, and he could try it before he actually had a building to do it in. The lead engineer got a real good look at multiple aspects of his equipment layout that looked great during CAD phase. You can spin that axis all over the place, but then when you put an avatar in the space and try and reach up and grab the valve, that's a change order coming, right? Adding the visual component to a digital twin was just the thing that needed to push it forward. And of course, the tool we had was appropriate for our level of engagement because we're not game designers, we're not movie set designers or directors. We're just not going to be those people. And the particular package with Siemens allowed us to pull in multiple data sets. And because it was greenfield, we could structure the data however we darn well wanted right from the get-go. No problem there. We pulled in multiple data sets, connected them all, and had them available present. Now, you'll notice that in this particular picture, the steps are floating in midair. Remember I told you we're actually building before we finish the design? We also wrote some bots based on the availability of what this software package had for us that allow us to update our designs, our P&IDs, our process models overnight. Any changes made by the designers and the crew, they come in the next morning, it's all in VR. They can pop their headsets on, or they can go through a flat screen like Minecraft, however it is that they're doing their reviews, and they can see their change. It was so powerful that the people running methanalysis have set up their own VR labs so that the people who are doing change, managing change, can now make that change, walk across to another room, light up their model, put on their headset, check it, yeah, I like it, it makes sense. I'm going to write a procedure based on what I just did, and over they go back to their cube. And I'm still not in a digital twin space. It's not really a digital twin yet. But the visual component accelerated the whole thing exponentially. And by the time we're done, when the real construction and the virtual construction come together, as our introductory speech said, it will be birthing a digital twin, and the twin will have a twin. And if Steve is successful, we'll have a brownfield twin sometime after that. And then if Texas is successful, our Texas site that's doing the training, we're going to globalize pretty quickly. Who knew? Who knew you would do that just by adding a visualization component? I didn't know. It was just tumbled upon. Lessons learned. Brownfield. Brownfield is hard. Steve is working very hard on his particular project, and I wish you great luck, sir. Legacy sites and acquisition sites. Don't start there. No. Global training and workforce development. Yes. We have a younger and younger workforce, as many of you have been talking about through the course of this ARC. Getting them, okay, I'm going to back up and tell a story. 2 weeks ago, my peer in Texas went to a middle school, put an Oculus headset on some various students just to introduce them to the concepts of lockout, tagout. That's something most college kids don't get. We've just influenced the future workforce through virtual reality. What we're going to do in the future is repurpose our digital twin for the same thing. The kids are never going to know it's a digital twin. They're going to think it's a video game. But who knows what craft skill or science major they may end up with now because they've been exposed to something early in life and it cost us nothing to do, is in addition to, because we were going to be doing it anyway. Hardware agnostic and software agnostic. This one gives people a lot of heartburn, gives management a great bit of heartburn. Talked to Dow about this after their great presentation. The words were said out loud in that presentation. Every 2 years this technology changes. I've been trying to hide that from management. They don't like that. They want to make an investment and they want it to stay in the ground, 10 years. They want it to stay on your desktop 10 years. Okay, Windows 2008 servers. You got them? Yeah? Yep. Yeah, what kind of frame rate you getting off of those if you're streaming your live data? Be agnostic and be prepared to make the case that you're going to have to be willing to invest on a continual basis, because even though this is not the Wild West, your decision makers and particularly the people in charge of product and loss sheets are going to think it's the Wild West because of the money that you're going to need to turn over on some semi-regular basis. Return on investment agnostic. Remember I said that back in college, I was learning CAD and it was a shock to me that people don't think three-dimensionally. Keep that in mind when you're talking about digital twins. Most of your non-technical folks, they don't, that definition of a digital twin, that was amazing. They don't really see this. So you have to remind them. Back in the days of early CAD, the drafting managers pushed back on CAD. Any of you remember that? You had to prove this software has some value to me. We're going to track your value. I want to see that this is really better than a T-square in Vellum. Does anybody do that today? Or is it just the tool you use? You're going to have to be return on investment agnostic. When management comes to you and says, I need to understand the value of what you're doing, it's good for you to be able to take your digital twin and say, okay, look, this is what happened safety-wise. This is the change we made in the real world based on what happened in the virtual world. And this is the cost you saved based on the input of a subject matter expert who knows what these change orders cost. Now, yes, we understand, sir, ma'am, you're going to still spend the capital. We know it. But now you're not going to spend it on a change order like this. You're going to spend it on something more worthwhile. And then later on, they're not going to ask you about return on investment at all, so kill those dashboards. Safety is priceless. The safety component from digital twin, the safety component you see from getting to a digital twin, it's amazing. We have added structures to our methanolysis plant that we had no idea we needed. Once we got at least the beginning of the digital twin in place and could walk through our own plant site at human scale, we made changes that probably will end up saving lives. No joke. There was a mezzanine level that only had one means of egress. Looked great in CAD. You put two operators in a virtual room in there and start feeding data from a pi model, which is fake because we haven't started up the plant, but you got the pi data. And then you add an incident because incidents are built into the software. I could add a high pressure fire. And it suddenly became apparent to the two operators that were doing the job safety review on this mezzanine level that they can't get off the mezzanine level fast enough. There's only one entrance and exit, and it's by ladder. So what do? We made a change. We have a second egress. We're just talking about changing ones and zeros in a CAD program right now. It was awesome. Lockout, tagout, permitting. You can train all of that ahead of time. You can push it out to the field. Operating procedures, third-party efficiencies. I don't even remember why I put that there. Execution forces. I don't remember why I was thinking with that one either. E-commerce. Remember that Bank of America graph you saw this morning about investment? Remember blockchain and all those things that come and go? Those actually are helpful for this. And data on the go. So what we have down here is an early view. I know you can't see it, it's eye chart-ish. It's an early view of one of our polymer feedstock buildings. It's just about to go live. If you drive by, you can see a good portion of those walls are up. Some of the equipment is in, the roof is not on. But that is all an accurate representation pulled in from CAD, multiple contractors, civil engineers, loop diagrams, multiple bits of data. That took me, I don't know, that builder takes what? Maybe a couple of minutes to chunk through a lot of data. That tells me that later, when this does become a twin, the sustainability part of that, keeping the twin alive, is going to be much easier than I originally thought. So the bottom line message for me is, if you want to go to the bar, ask some good questions, get a good martini, add visualization to your digital twin growth program, and don't start in a brownfield, start in a greenfield where you have control over the data and your own destiny. Does that kind of fit with what you guys were saying? Use the data wisely. Generate the data wisely. And choose your partners wisely. All right, I'm done. Let's get out of here.